Hello there! In this tutorial, we are going to write a Godot shader that can hide or reveal a 2D graphic in a couple of different ways. To make all of that work, we are going to learn about a really important concept in shaders, and that is called a UV coordinate. The system is fortunately quite easy. Imagine you have some kind of graphic, and this graphic is going to have a bounding box. I suppose one thing I should mention is when you work with graphics, you always work with rectangles. Something like this one here, for example. Even though only some pixels are visible, you always have some transparent pixels to get to a rectangular shape. The picture format here also doesn't matter. JPEGs, PNGs, GIF files, they all work in the same way. Now, what the UV coordinate is going to do is give you a position on this bounding box. And this position always starts at 0 and goes to 1. Also, we have this one for X and Y. For example, all the way in the top left, this point, we would have a UV coordinate of 0 and 0. One for X and one for Y. Although this doesn't help you too much. So let's do another example. Imagine we are somewhere down here. On the horizontal side, we would still be fairly early on. Let's say this one could be 0.1. However, on Y, we have to go all the way down, and then somewhere down here, let's say this one could be 0.9. And that is basically it. Via the UV coordinate, we're getting 0.1 and 0.9 for this pixel position on the graphic. It doesn't get that much more complicated. In practice, in Godot, we simply get for every single pixel a vector coordinate of the position, and then we can do something with that. What that specific thing will be, I will show you in just a second. First of all, though, a couple of important notes. Number one, the numbers for the UV coordinates always start from 0 and go to 1. This applies even if you resize the graphic or if you change the dimensions. We are not working in pixels here, that's really important to understand. But that's basically it. All that you really have to understand is that the UV coordinate can get us the position on the graphic of one particular pixel. And that we can use for a whole bunch of things. For example, we could change the color of a pixel or only draw on one side of the image. To demonstrate that a little bit better, here we have a grid of an image. So imagine that this is some kind of image and each of those cells is one pixel of that image. So for example, all the way in the top left, we would have 0 and 0 for X and Y. On the cell to the right, this would then be 0.2, and for Y, this would still be 0. The one thing that you always have to understand about shaders is that we are going to run shader code for every single one of these cells individually. And all of this happens in parallel, meaning at the same time, every single pixel gets some kind of update. And that we can use incredibly well. For example, we could run some code that only these pixels get an alpha value of 1. Or to make this a bit more specific, we could tell the shader to only draw the graphic if uv.x is greater than 0.6. Everything else we just want to discard. Another thing that we could be doing is measure the distance. For example, if this is our center, we could check for every single pixel how far they are from the center, and then only draw pixels that are within a certain radius and ignore everything else. That way, you would draw a circle via a shader. And that's basically what we are going to do via these UV coordinates. It's an incredibly powerful system. Later on, we can also use that system to sample colors from a texture. But that's going to come later. For now, don't worry about that. Instead, I want to work inside of Godot. I already have one scene open. I called it UV, and this one right now only has a single node 2D, so nothing is going to happen. If you look at the bottom, we only have icon.svg and the scene itself. Now I want to create a sprite 2D from the icon.svg. So I'm just dragging it into the viewport, and now we have an icon. This I also want to rename. Let's call it UV Visual. And I should mention, we are going to create a visual shader and a code-based shader. We are starting with the visual one, simply because I can use that to show you what's going on a little bit better. Anyway, after that, I want to go to Material, create a new material, a shader material, click on the sphere, click on Shader Empty, and New Shader. And now the type of shader we want to create is a visual shader. We still want to create a canvas item shader, so 2D, And then we have the name. By default, this will be UV, but I want to create UV visual.trace. That way I can separate later on that we have a visual shader and a code-based shader. Click on create, and now if you click on UV visual, so the shader file we just created, there you can see the visual shader. And let me rearrange everything so we have just a bit more space. What I want to start with is the actual UV coordinates. For that, we will need a node that is called UV. And if you type that in, you get a whole bunch of UV functionality. But we only care about the first one, vector2 UV. This I want to add. And now we get another input. From this node, you're also getting the color, you're getting time, you're getting the vertex nodes. There's a lot of stuff in there. But at the moment, we only care about UV. And now, if I click on the eye, you can see some weird image. So what's going on in there? And well, the main thing you have to understand is if Godot wants to draw anything, it needs to have a vector 3, where we have a red color, a green color, and a blue color. Let me draw that actually. We want to have a vector 3 with red, green, and blue. What is happening in this image is that Godot has information for red and green. For both of those, we're getting values between 0 and 1. However, for blue, we have nothing. So the values for that one will remain 0. And now, if you look a bit more closely at this graphic, you can kind of see that. If we stick all the way at the top, so only look at this narrow band up there, and let me add a bit more separation. There we go. Starting all the way on the left, we have pure black, because in there we have no color information, or rather, the color information is 0. But all the way on the right, we have a pure red, because for the color value here, we have a 1. And then to get from one to the other, we keep on adding a higher number. And the very same thing we are doing on the vertical axis. We are still starting all the way at the top. There we get full black. But if we go all the way down, then we are getting the full amount of green. And that is because on the vertical axis, we are using this value. That starts at 0 all the way at the top, and then the further down we go, we're getting to a 1. And this I can actually demonstrate a little bit better if I clean all of this one up just a tad. If you click on the little arrow next to the eye, you get the red and the green color. Or in other words, for this vector 2D, we're getting the x and the y values. If I click on red, you can see we're starting all the way on the left, and then the further to the right we go, we're getting a brighter color. And for the green color, we're doing the same thing, except on the vertical axis. And if we combine these two values, we're getting a red and a green color, but no amount of blue. And this is why you are seeing this kind of graphic. I hope that makes sense. Initially, when you see this for the first time, it can be a bit weird. Also, this thing at the moment doesn't do very much, but that we can work on. If you want to use this color, you can simply connect it to the color, and now we can see that, well, we get the same output that we have just seen in the editor. But that isn't terribly useful. I think a better way of approaching that is via the alpha values. And for that, for now, I only want to work with the red values. Those I want to connect to the alpha value and not use the color anymore, so it's a bit easier to see. And now, if I zoom in, you can, I think, see somewhat what's going on. To understand what's going on here, remember, we are looking at all of the pixels of this graphic. And more specifically, we are looking at that pixel's uv.x, so their horizontal position on this image. If this pixel is all the way on the left, so somewhere here, then this value is going to be 0. And that 0 we are passing into the alpha value. Meaning if that pixel is all the way on the left, we are going to get an alpha value of 0. But the further we are getting to the right, the greater this value will become. And if we are on the right border, this value will be 1. So we're getting the full alpha value there. The same thing we can also do on the vertical axis. If I use the green color, then we're getting a vertical gradient effect. Except for this one, we are checking, and let me actually display the green part. Any pixel that is all the way at the top is going to have a value of 0, but the further down we go, the higher the value will be. And as a consequence, the more of an alpha value we get. And that is already a really important part to understand, and I hope you could follow so far. If you don't, I would very much recommend to re-watch the earlier part. This is very important to understand. Because next up, I want to work with another function. If I right-click and add another node, I want to add a step function. The way you are going to use that is you have to specify an edge or a limit and then a value. In my case, I want to use the alpha value and then set an edge of, let's say, 0.25. And if I now connect the output to the alpha value, we are only drawing one part of the graphic. And also, if I look at the preview for this node, we now have a bit of black at the top and lots of white at the bottom. The step function, fortunately, is really simple. It wants two arguments, an edge and a value. After that, it is going to return one of two values. It will return a 0 if the value is below the edge. However, it is going to return a 1 if that value is greater than or equal to the edge. Or in our example, we are currently checking on this thing if we are somewhere between 0 and 1. If the value we are currently working with is below 0.25 or whatever value we specify, then the step function is going to return 0. So this top part is going to be black. But for every other pixel with a greater value, we're going to return 1. Because of that, the bottom part gets a pure white color. On top of that, if you change this number to, let's say, 0.5, then we get exactly 1/2 black and 1/2 white. What we can also do is create a float parameter where we can get some input. So let's call this one slide_progress. This I want to connect to the edge. And now you can see that the preview has disappeared. That happened because to get a preview, you need for a parameter a default value. If you enable that one and set this one to 0.5, then you get the 50-50 split back. Also, I want to set a range from 0 to 1. That feels a bit cleaner. After we have that, we can go to the inspector and look at the shader parameters. Now I can hide or reveal this graphic very easily. Also, there's one more thing I want to talk about. If I set the default value for this thing to 0 and do the same thing in the inspector, so now slide progress is 0, which means at the moment we are checking from the input if any of these uv.y values is greater than or equal than 0. If that is the case, we are going to return 1, and this applies to literally every single pixel. Since the lowest value from input is going to be a 0, every single value will be greater than or equal to this 0. That way, we're getting a pure white. But anyway, with that, let me set this to 0.5, and now we have a pretty good start. That is the first thing I talked about in the slides. But there's one more thing that you also see fairly often that is really useful to know. And that is, imagine you have the full graphic, but you don't want to show all of it. Instead, you only want to get some kind of circle around the center. The only thing you want to display is this one, in other words. That you can do via shader very easily. All you need is, first of all, the UV input. This we already have. But on top of that, you want to specify some kind of center point, which we can do via a vector to constant. This could also be a parameter, but in our case, we don't really need that. For these values, I want to have 0.5 and 0.5. These numbers are important because imagine if this is our entire graphic, we want to be right in the center. And since the values go from 0 to 1, 0.5 is right in the center of those numbers. And now, basically all I want is the distance between the center and the current pixel position. That number we can get via distance 2D, which is another node that wants to have two inputs, which are going to be two vectors. I want to get the UV input and then the current center. And now, if I show this node, you can see we have a circle. And I hope the logic for that one makes sense. Remember once again, and I keep on repeating myself, but it's really important to understand. When we are working with a shader, we always look at every single pixel individually and then run some code. And at the moment, we are checking the distance between a center point and some other pixel. For example, we could have a pixel up there, we could have a pixel here, we could have a pixel there-ish, and we could have a pixel very close to the center. Via the distance function, we are going to get the distance to all of these points, which is going to return a float. Let's say, for example, to the pink point, we have a distance of 0.7, while the distance to the red point is 0.05. These numbers we can now use for the transparency, which is what we're getting down there. The closer we are to the center, the lower the distance is, and since that will be our alpha number, the darker it gets. Or in other words, if I connect this distance to the alpha, we can see that, well, this is a bit hard to see, but all the way in the center, we have very low alpha values, but the further out we go, the more of the graphic we can see. To make all of this a bit more visible, we can use the step function once again, which means I want to pass the value that we are getting from a distance in there, and then for the edge, I want to specify, let's say 0.4. If I now show the result, we can see we have a nice clean circle that we can then use for the alpha value, and there we go. Now we are cutting out the inner part. Although, that being said, we want to do the exact opposite. We only want to show the inner part and then get rid of the rest. To get that kind of result, we can do one of two things. Number one, I want to create another node, and this one is called 1 minus. If I drag the step value in there and then show it, we're getting the exact opposite. And if I drag the result of that value into the alpha output, we are only showing the center. So what happened here? And to understand that, remember, we are once again looking at every individual pixel. If that pixel happens to be in the center, it is going to be 0. However, if we are in the outside bits, that value is going to be 1, or 1.0 to be a bit more specific, and 0.0, but doesn't really matter. What 1 minus is doing to that value is it simply gets 1.0 and then subtracts the value that we are getting there, either 1.0 or 0.0. Now, if you subtract 1.0 from 1.0, the end value is going to be a 0, meaning all those white bits are going to become black. If you subtract 0.0 from 1.0, the result is still going to be 1.0. As a consequence, all of the center part will become white. We basically inverted an alpha value. That's all that's happening in here. Although this is not actually what I want to do. Instead, what we can do, when we are applying the step value, we can set the value we're getting from the distance as the edge. And then for the current value, set this to 0.4. And then we have inverted the entire thing as well. If I connect this to alpha, we're getting the same result, which is quite a neat trick. Via the step function, you can either get one value or the inverted value of that. It's super handy. To understand what's going on in there, remember for the edge, we are getting a value between 0 and 1. But this value is now going to be our edge, and we want to check if this 0.4 exceeds it or not. Which means for the first 40% of these values that we are going to get, the 0.4 is going to be greater. But after that point, it's not going to be anymore. Hence, we're getting the black area around it. But that is basically it. If you play around with these values, I think they're going to be fairly straightforward. On top of that, what we can also do is add another float parameter where we can set the circle size. I want to assign this as our value and then set a default value of 0.4. That way we get the circle back, and also I want to set a range of 0 to 1. That way inside of the inspector, we can change the circle size. The last thing that I want to cover is how to combine these values. And for that, once again, we are looking at one individual pixel that at the moment has some kind of alpha value, either from this thing or potentially from this thing. So for example, if we have a pixel that's all the way in the bottom right, we would sample this point on the slider scale or this point on the circle. For the slider, we would get a 1, and from the circle, we would get a value of 0. And ultimately, all that we want to do is to check if our current pixel is in either one of them. And if that is the case, we want to show the pixel. If that is not, then we don't want to show the pixel. So ultimately, at the moment, the shape that we want to display is going to look something like this. where we get the rectangle from one shape and the circle from the other. Now, getting that shape we can do in a couple of different ways. The easiest is to simply add these two numbers together. I want to add another node that is simply going to be called add. Then I can get this slider step value and this circle step value. If I now show the preview, we are getting roughly the shape I just outlined. I suppose I should also mention that if we are in an area where we have both values, so for example, in this bit, the alpha value would actually be 2. But if you have any value greater than 1, Godot will just ignore it and you get a 1. You simply cannot have a value greater than full transparency. So finally, we can use this for the alpha value. And now, if you look at the inspector, we can change the slider and we can change the circle. On top of that, what is even better, if you look at the float operator, at the moment we are using add, but if you use subtract, you're getting another shape. If you use multiply, you get another shape again, and then this you can continue forever. And all of these things are defined by the math. I want to stick with add. If you crunch the numbers and do some examples, then this should make sense. I'm not going to go through every single example. But via the system, you can combine different alpha values super easily, which is incredibly handy. But all right, with that, we have covered an incredibly useful concept. So all I want to do now is clean this thing up just a bit so it doesn't look as atrocious anymore. All right, I think that is much more readable. And well, with that, we have a visual shader. Next up, we can do the code-based shader. For that, let me minimize the shader editor, and instead, with the UV node 2D selected, I want to add another sprite 2D that I will rename to UV code. After that, I want to go to material, create a new shader material, click on the sphere, click on shader empty, new shader. We want to create a regular code-based shader. Still a canvas item, although the name I want to change to UV_code. I can now click on create and then click on the shader file, and now we have some code. On this code, we don't need the light shader and we also don't need the vertex shader. The only thing that I care about is the fragment shader. First of all, in there, we have to figure out how to get the UV coordinates. We simply type UV, which is going to return a vector 2. Which means what we could, for example, do is set the color.rgb to a vector 3, where we get uv.x, uv.y, and then for blue, a value of 0.0. Now don't forget the semicolon, and then we are getting the same thing we have seen earlier. Alternatively, if you replace uv.y with 0.0, then you can see only one side, or if you change uvx to 0.0 and the second part of the vector 3 to uv.y, then we are getting the vertical gradient. I suppose I should be a bit more specific here. At the moment, this doesn't look exactly like what we had earlier, because in there we only have black and white values. That is because for those values, we had the same value for all three parts. Meaning uv.y was used for x, y, and z of the vector. The same thing applied to uv.x, and there we go. Now we get the exact same thing. If you only supply a single value to a vector 3, then this value will be used for all three parts of it. Because of that, we're getting a grayscale image. However, in our case, this is not exactly what we want to do. Instead, I want to create another float. Let's call this one the distance to top. The value for this is going to be uv.y, which right now is not going to do very much. But that value we can use for color.a. So in there, I want to have distance to top. And now we can see once again that we have more transparency at the top, but we can see the entirety of the graphic at the bottom. That's a good step closer to what we have done with the visual shader. However, we don't want to have a gradient. We want a sharp cutoff point. For that, we will need the step function, which we can use in code just as we have inside of the visual shader. And the same thing is going to apply. We will need a limit and a UV. Or I guess it's not a limit, it's an edge in the visual shader. So we're going to recreate this one node. And for now, just to have something, let's say 0.5 in there. If I now save all of this, we can see that we only have 1/2 of the image. On top of that, we can make this thing a bit more interactive. I want to create a uniform with a floating point value that is going to be slider progress. For that value, we want to have a range. So hint range, I want to go from 0 to 1 with a default value of 0.5. And once again, don't forget the semicolon. This value we now want to use inside of the step function with slider progress. And now if I save all of this, we can look at the inspector, their shader parameters, and there I have this slider progress. That works really well. And that covers the first part of the visual shader. Now we can slide the graphic in and out. Next up, I want to work on the circle. For that, first of all, I want to set a center point, which is going to be a constant. It could also be a uniform if you want to have a custom center, but that you could do in your own time. I want to have vector 2 center, which is going to be a vector 2 with 0.5. After I have that center point, I want to once again work inside of the fragment shader and create another floating point local variable. Let's call this one distance to center. For that, we simply need the distance, and for that, we will need two vectors. One is UV, and the other is the center. And with that, Godot should stop complaining, and now instead of distance to top, I want to have distance to center. And I can save, and now we get the same thing we have seen earlier, where in the center, we have basically full transparency, and the further out we go, we're getting less and less transparency. But once again, we want to have a sharp cutoff point. For that, we will need the step function. Whatever we are getting returned from the distance, I want to wrap inside of step, and then set an edge, for now 0.4. And then once again, we're getting the center cutout, which you can also reverse. And I'm running a little bit out of space. Let me try to add a bit more. Okay, not going to work. What I'm going to do is to expand all of this, and then you can see the code a bit better. To invert this shape, we can do one of two things. Number one, we can simply do 1.0 minus whatever we have gotten. That way we're getting the inverse. Alternatively, we can simply switch the edge and the value. I want to have an edge of the value from the distance. And then the current value will be 0.4. The end result is going to be the same. After we have that, I want to create another uniform. Let me copy the slider progress actually. I want to have I think I called it the circle underscore size. This value is what I actually want to use for the value inside of the step function. After we have that, I can end the distraction-free mode, and inside of the inspector, we can now set the circle size, although this slider progress we have lost. To get that one back, we have to add these two values together in some kind of way. The easiest, I suppose, would be to simply add one to the other. So distance to center plus distance to top. And then if I save it, we're getting both values. So that works perfectly well. What we could also do is use the max function, for example, where we always get the larger of two values. I want to check the maximum value of distance to center and distance to top, and then select the larger one. The end result is going to be once again the same thing. If we change this to minimum, then we are getting some other kind of behavior. It's kind of hard to describe. Now, once you have all of that, you can simply play around and see what kind of effect looks good. If you experiment with the math, this is actually fairly doable. But alright, I hope with that you have a much better idea of what the UV coordinates are doing. The last thing we want to do is for me to delete this one line because it's annoying, and then we can do an exercise. I want you guys to create a new sprite 2D with the Godot logo. On this new sprite 2D, create a shader and then hide and reveal the graphic via a diagonal line, just like you can see in the video right now. Also, this should be a visual and a code-based shader. Try to do both. But pause the video now and see how far you get. Back in Godot, I want to first of all create another node 2D, which I will rename to exercise. I want to add another sprite 2D, which is going to be a UV exercise visual. Let's start with that. I want to once again create a new shader material, then create a new shader, which is going to be a visual shader. Canvas item and UV exercise visual for the name. Then I can open the file, and there we go. Also, let me only show the one image we care about at the moment. Now, obviously, first of all, we will need the UV input. And on there, I want to get the red and the green color. Let's show the entire color for now, though. And now we have to think about how to approach this problem in the first. So we want to work on this graphic and then create some kind of diagonal line that we can then increase or decrease in size. To approach that problem, let's go step by step. And first of all, only show the top part. I want to reveal all of this and then hide the bottom part. To get that, I want to use the subtract node and subtract the x values from the y values. And now, if I show this, we are getting exactly that. To understand what's going on here, let's start with the corners first of all. The top left is really easy. Both red and green, or x and y, are going to be 0, and 0 minus 0 is still going to be 0. Hence, we are going to get pure black. The bottom right is also really simple, because now both red and green are going to be 1. And 1 minus 1 is going to be 0, so once again, we're going to get a black color. However, these other corners are much more interesting. Because on the first one, we have a red value of 0 and a y value of 1. And 1 minus 0 is going to be negative 1. That's the value for this corner. And since we cannot have negative transparency, the lowest possible value is going to be 0. Hence, we have pure black. Finally, we have the top right corner. For this one, we have a red value of 1 and a green value of 0. The result is going to be a 1. Hence, we get a pure white color. And then the further away we are getting from that point in either direction. So let's say we are either here or we are here. If we are on the top point, the red value could be something like 0.5 and the green value could be 0.1. The end result for that point would be 0.4. So for this point, we are roughly getting 40% transparency. And then for the second point, this one, we have an x value of 0.9 and a y value of, let's say, 0.5. The end result is also going to be 0.4. So down here as well, we have 0.4, the same value we had up there. Now, to get to this kind of pattern, the best way is to just look at a whole bunch of shaders and at some point you see some really good recipes. That's how everybody learns, and there's a good chance that you spent 20 minutes trying to figure this one out and nothing worked, and now it looks incredibly simple. And that is how you learn shaders. It's a horrible process. But anyway, next up, we actually have another trick. So at the moment, we only have one side, but we rather want to have a diagonal line, something like this. To get that, I want to create another node, and this I want to have for the absolute values. If I now drag this subtract in there and reveal it, we have a diagonal line. In case you don't know what absolute does, it's a math function that turns any number into a positive one. So 1 is going to stay a 1, but negative 1 will become a 1. Or if you have something like negative 0.5, it would simply become 0.5. We're turning a negative number into a positive number, but if we have a positive number, we just keep that number positive. That's all that's happening in here. Now, the reason why we are getting this outcome is that for this graphic, the further we go down left, the closer we are getting to negative 1. But since we cannot go below 0, all of these values are going to be equally black until we are turning them into positive numbers. Then all of a sudden, we are going from a 0 point down here, where x and y are equal, to a greater and greater value. And as a consequence, The further down left we go, the brighter the value becomes. Finally then, we can use the step function for a clearer cutoff point. For that, I want to set the absolute value as the value, and then for the edge, I want to have for now something like 0.2. If I now show all of that, we have the diagonal line that splits the two sides. That could be the alpha value, and there we go. Now we have a diagonal cutout. If we add a float parameter, let's call this one simply progress with a default value of 0.2 and put this one in there. Then from the inspector, we can customize this value just fine. Also, there should be a hint with the range from 0 to 1. And now we can show or hide the entire thing super easily. And that is basically it. So let me just clean the entire thing up just a bit. And I think that looks more or less respectable. Let's do it like that. There we go. That would be the visual shader. Next up, I want to create one more sprite 2D inside of the exercise node, which is going to be UV exercise code. For that, once again, material, new material, shader material, sphere, click on empty shader, shader. We want to have a shader, canvas item, and UV exercise underscore code. Click on that one, and then we don't need a vertex shader and we don't need a light shader. Inside of the fragment shader, I want to create a new floating point variable, which we can call distance to center. The value for that is going to be uv.x minus uv.y. Then don't forget the semicolon. And after that, we have a distance to the center. That value we can use right away to update color.a, which is going to be distance to center. And then we are once again cutting out the bottom left, but keep a top right triangle. To get both sides, we have to wrap this calculation into the abs function to get the absolute value. If I now save all of that, we have a diagonal cutout. Next up, I want to pass all of that into the steps function, where we will need an edge and a value. And to keep in line what we have done with the visual shader, the absolute value is going to be our value, and then some kind of progress parameter will be the limiter or the edge, which means I want to for now have 0.1 and then the absolute value. And with that, we get a center cutout, although this needs to be a bit more customizable. So I want to create a uniform float. Let's call this one progress, and the value for that is going to be between 0 and 1 with a default value of 0.1. After that, I can paste the progress in the step function, and then we should be good to go. If I now go to shader parameters and play with the value, we are getting the very same behavior. So that's looking pretty good. And well, with that, we have UV coordinates and a really nice shader. So I hope all of that was useful.